Thank you, John. So, guys, if I'm talk about routing protocols, we have a routing in the two ways, right? As we know that. Okay, I'm just going to start from very basic level. Okay, a very basic level, like I'm just assuming you don't have any idea of the routing protocol, right? Forget the routing protocol. Forget it. So routing, we have a two types. Okay, one we have a static routing, as we know that. One we have a dynamic routing protocol. Ron, I'm recording. I'll save this recording to you. Don't worry. I'll upload the rap. Don't worry. I have a static routing and I have a dynamic routing protocol, right? In dynamic routing protocol, right, we have some flavor, right? The flavor we have, one we have a IGP protocol and one we have a EGP protocol. IGP and another we have a EGP one. In IGP protocol, in IGP protocol, we have some flavor. The flavor we have a OSPF protocol, right? We have a RIP protocol, right? We have a, okay, start from the very basic level. The when the internet was growing, I'm not talking about the very basic protocol like ARPANET and GGP protocol. I'm not talking about that one, right? So starting from the RIP one that we know right now in the market, right? Okay, that we know right now in the market. I'm just going to start from that level, right? I'm not talking about the ARPANET, GGP was there, multiple protocol was there that we are not using right now. I'm just talking about which we are right now using. So we have a RIP in the market right now. Some companies are still using the RIP. Then after that, we have a IGRP came with the picture, right? After the RIP. And after the IGRP, we came with the EGRP protocol. This is how the thing had changed. Swami, I'm recording the video. I will share the video to you as well. So this after that, we have a IGRP one. And after that, we have a EGRP protocol. If I'm talk about, right?
Oh, sorry, I cannot record the video.
I'm recording it. I'll share with you. Don't worry. Okay. Because in sometimes what happened, I really have to give the every time permissions, right? I'll share with this video. Don't worry. So, okay, I'm teaching you right now ISS protocol. So I'm starting from the very basic level. Okay. Now IGP we have three flavors: RIP, IGRP, and EIGRP. Now, do you know the common thing about this protocol? Anyone knows what is the common thing about this protocol? What is the common thing? The common thing about this protocol is a distance factor. So maybe I have a question law, the EIGRP is a hybrid protocol, but still, yeah, they have a mechanism of the distance factor, right? I'm not talking about the detail level of that thing, right? Or how they are working on a hybrid, link state as well. The common thing about this protocol is a distance vectoring protocol. And do you know why in the market? See, on the time according to the 90s, 80s, if I'm talking 90s, 80s, or we can say the 90s, on the time this year, right? This was awesome protocol. Distance vector was awesome because on the time what happened, internet was not so huge amount of right? They have like a 1,000, 2,000, 3,000, right? And we had a very small organization. They have a 10 routes, 5 routes, something like that. They don't on the time we did not have a what we call multiple applications of there. Right now we have lots of applications, right? We have a Skype, Facebook, LinkedIn. On the time it was not this thing was not there. So distance vector protocol was awesome, right? And do you know what is the problem with the distance vector routing protocol? The problem with the distance vector routing protocol was this guy is doing the periodic update. This guy is going to do the periodic update. This guy does not have a knowledge of right? This kind of protocol does not have a knowledge about complete domain. If I'm talking about the complete domain in the sense of what domain is to a network or ACE number, I'm talking about a group of router. But the good thing about this protocol, right? If I'm talking the good thing about this protocol, this protocol require a very less amount of resources. A very less amount. You don't need to require the huge amount of, the processor, CPU, and memory. Nothing. But the problem is this guy does not have a complete knowledge of the domain. Domain in the sense of they don't have a knowledge of the complete information, right? For example, you are sitting on the router number one. एक मिनट यार मेरा ये थोड़ा it's not working. It's not able to write it. एक मिनट So now this protocol, right? This distance vector protocol is doing the periodic update. They don't know about the like a complete domain. Like it means that, for example, okay, I cannot draw the right. You can. It's not working. No. Oh, so R1, R2, we have R3, and we have R4. And take example, we have a R10 as well. So in between, we have a 5, 6, 7, 8, 9, so on. So if I'm talking about the distance factor, so if you're sitting on the router number one, you just have a knowledge about the router number two. Router number two has knowledge of the router number one and router number three. Router number three has knowledge of the router number two and router number four. Only the neighbor information you have, a detailed information I'm talking about. Just have a neighbor information. You don't know that router number one does not have a complete idea about the R10. Right? You can send the traffic to this guy, but you don't know, you cannot identify the best path, the best solution. Every router is going to identify the best one. So this protocol was good, but it is not designed for the big network. Right now, what happened? It's a 2-tier. We have a big network, right? This protocol is not suitable for the big network. Big network in the sense of what? I'm talking about the ISP perspective. In the enterprise level, you can deploy the EHRP protocol. Right now, in the enterprise level, because we have a lots of mechanism, lots of the modification has done in the EHRP protocol. So you can do the EHRP on the enterprise network. But if I'm talking about the very big network, like we have ISPs like the tier 1 ISP, tier 2 ISP, tier 3 ISP. For this kind of network, right, this distance vector routing protocol is not suitable. Then after that, what we have introduced, the protocol called as a OSPF. And what OSPF is doing, OSPF is first of all, it's a link state routing protocol, right? And the good thing about this protocol, they have a complete knowledge about area. So whatever the routers in your area, right? According to the Cisco recommendation, you can have a 50 to 60 router in your area, right? That's a recommendation. You can go for the 80 routers as well as whatever the routers are present in your area. All the router as a detailed and identical information or mirror copy. But the problem with this protocol, OSPF, right? The problem with this protocol, this requires a huge amount of process. Now try to understand the difference. If you have a look, this protocol require very less amount of resources, whereas linked state routing protocol require the huge amount of resources. Do you know the reason? Reason is very simple, because OSPF maintain the database table, or in the database table, what happened? In the case of AHRP, router 1 has just a knowledge of the router number 2. They don't have a knowledge of the router number 3. Router 1 has a complete knowledge of the router number 2. That is the distance vector routing protocol. But in the linked state routing protocol, what happened? Router 1 has a complete knowledge of the router number 2, at the same time router number 3. I need to maintain the complete information. And why do we need to maintain the complete information? So that I can draw a map of the topology, right? I can create a map, and based on that, every router is going to find the best path based on the SPF algorithm, right? I'm going to perform the SPF algorithm on the LSDB table, and from this LSDB table, I'll find the best path and put in this information in the routing table. So in that case, this SPF algorithm will be run on the LSDB, right? And in that case, what happened on the router? You need to have a huge amount of resources. To make a very simple, what this guy OSPF did over there on the time, they came with the mechanism called as an area. Why they introduced the area concept in the OSPF? To do the summarization. Remember the LSA3 concept? Whatever the routers are present in your area, like this guy, this is the one area, whatever the routers are there in this area, area number 0, we can say that this is the area number 1. So this guy R1, they know the complete detailed information about the own area. All this router know the detailed information about the own area. But between this guy, I'm going to share the what? Summary information, that is called as a summary LSA, right? Aggregation I'm doing over there. So that the load will be not increased, right? So that the load will be not increased on the routers. So it was very high. Then after that, what happened? I introduced the area concept, and due to the area, what happened? Now each router does not require the much resources. It is something like that. If I'm going to tell you, hey, do one thing, you have to manage the 1,000 people. You are a single guy, you have to manage the 1,000 people. So what happened? You have a load on the 1,000 people. But if I'm going to divide the work, okay, now you have to just manage the 100 people. So this is good, right? 100, manage the 100 people, and you can easily troubleshoot. Get it? The reason to introduce the area, so that the load will be not increased on the router side. I'm again repeating, I'm talking about according to the 90s, 80s on a time. Not 90s, it was the 90s. After the 90s, 85, this protocol has came in the picture, right? And all was in the 1993, we introduced the concept of classless. So whatever the protocol came before the 1993, all was classful. Itself in the 1993, we came with the concept of classless. So whatever the protocol we were discussing right now before the 90s, 1993, all were classful. So OSPF version 1 has came in the picture in the 90s, 80s, 8, I think so, if I'm not wrong. You have to check your RFC. Near around 1988 or 1989, near around. But do you know all this guy? If I'm talking about RIP, EHGRP, OSPF, now you have a clear picture what is the meaning of distance vector routing protocol and what is the meaning of linked state routing protocol. And if somebody will ask you what is the main difference is happening, this guy is doing the periodic update, link state is doing the incremental update. Whenever something has changed, I need to send that particular amount of information. Although another reason is that if somebody will ask you, hey, which routing protocol I should consider to deploy in the network, it's depend on the scenario, right? How many routers you have, how many routes you have, and how much amount of process you have, right? If you have a high amount of process, go for the OSPF. If you have a really low amount of process, go for the EHGRP. This two one is totally legacy now, so forget it. But again, the concept comes in the picture. Do you know the if I'm going to summarize this two guys, two protocol, the EHGRP protocol is applicable for IP. Now the IP is what? It's a transport protocol, right? Transport protocol in the sense of I'm not talking the TCP and UDP, a transport layer protocol. They can carry the information, the piece of information called as a packet, right? So the IP can carry my data. Then after that, we had IPX as well as an Apple Talk. This was a different, like, addressing mechanism over there. Then IGRP also support this person. And OSPF was a pure IP-based protocol. It only supports the IP. Ninety eighties, it means that the gap will be 1985. I'm talking in this range, 1985 to 1990s. Right now, we are all discussing over the near around this situation time. Let me check what them came in the picture. Not there. Two is 1998. What's the one? I think so. It came in the 1988, if I'm not wrong. Now, try to understand one thing over there now. On the time, 90s, this time, right? If you want to provide the communication between these two guys, what you need? What is the basic thing you need? Tell me. If you want to send any data to the PC1 to the PC2, what is the basic thing that you need? You need I'll tell you, you need IPs. Guys, now pay attention. This is now we are moving in the ISS. We need IPs to provide the communications. But during the 90s, 80s, right? What do you think? IP was dominant? No. Before the IP, it was something called as a different addressing mechanism. It was a different addressing mechanism, right? And that address mechanism is called as a CLNNP. CLNP or CLNS? CLNS, I think so. It's not a CLNS. Connectionless network services before the IP. So it means that on the devices, right, we need to define the something called some CLNS address like this 1 2 3 4 5 6 7 8 9, something like that, like a IP addressing, like that IP addressing 8 9 10 11, something like that. There's some range. I'll show you, don't worry about that. In when I'm doing the ISS protocol configuration, right, I'll show you. CLNS was a addressing mechanism to define the address on the devices. And this address we are defining on the device, not the interface. Forget the IP right now. Try to understand the CLNS. Why the CLNS is not using right now in these days. I don't know, some maybe some users, I'm not 100% sure, but yeah, we are totally pure on the IP based communication right now. To provide the communications between these two guys, right? These are the CLNS address guys. To provide the communication between these two guys, we came with the protocol called as a ISIS. If you want to exchange the information, if you want to exchange the CLNS address, right, we need to run the ISS protocol. So ISS introduced not for the IP. ISS was introduced not for the IP. It was a totally a dedicated protocol, right, for the CLNS. And it is also a Castro algorithm. But do you know why we are not using the CLNS in the nowadays in the market? What's the reason is that the reason is not using the CLNS in the market now. See, I'm not going to move more detail about the CLNS protocol. This is totally like we are not using nowadays. Okay, I'm just let you know, right, why we are not using the CLNS. What's the disadvantage was there? Of course, maybe some advantage was there, but you just try to find on the Google, you will not find any like a suitable answer of the CLNS. I have been going through the like many days over the CLNS, right? The main reason to CLNS I'm not using this guy. The problem is that CLNS, you cannot do summarization. Now tell me, these are the address you have. 1 2 3 4 5 6 7 8 9 9 10 11 12. This kind of address you are going to define the CLNS like that in the digit format. Like IP addressing you're defining in the digit format, same way as you are defining the CLNS address. The problem with the CLNS address, right? On the time then the CLNS was introduced, right? It was good because on the time there was not so much user, right? So there is no need of summarization. But when the internet was growing, the CLN address was populated a huge amount of traffic, right? Sorry, huge amount of information that router is maintaining about the CLN address. Then you see that each host you are going to define the CLN address. So take example right now, just take example of this scenario right now. In these days, you have a 20,000 host in your network. All the 20,000 hosts will share the own CLNS address to whom? Router, and router need to maintain that information. Are you able to do the summarization? No, you can't do that. And the second issue with the CLNS is that they have some problem with the, I cannot say that you cannot do the multi-homing. They have this guys, multi-homing. Multi-homing is what? The meaning of multi-homing, in a classical multi-homing, a network is connected to whom? Multiple providers using its own range of the addresses. Multi-homing is what a user is connected to the two different network, a service provider. That's the meaning of multi-homing. So CLNS has an issue with the multi-homing. But the good thing about the ISS protocol, it was a layer 2 protocol. It is a layer 2 protocol. It means that they don't have any IP, no TCP, no UDP. So OSPF and ISS protocol, the origin of OSPF and ISS protocol at the same time, right? Not the like it's just a gap of the 6 months or 1 year. And according to the some docs, they think that ISS comes in the picture first, right? And what OSPF did, OSPF utilizing the all the features of the ISS protocol. OSPF utilized all the features of the ISS protocol. So ISS comes in the picture first, and then after what happened, ISS was very good protocol because it was a link state protocol. Link state means what? Now this person has a map of the topology. ISS also works on the area concept. So what OSPF did, OSPF utilized all the features of the ISS protocol according to the some docs, right? The source of this thing is some docs. So what OSPF was there? So OSPF introduced for the IP because on the time 90s, the IP was dominant. ISS was not, because sorry, CLNS was not, because CLNS has some issues, right? IP was good because on the IP you can do the summarization. We have seen the summarization, right? We can do the multi-homing, we can do the lots of things. But the common thing, right? The common thing about the IP and CLNS, do you know in networking we have a two types of data communication. There you can see the transport data communication. We can do the data communication in the connection oriented way and connectionless. Connection oriented means what? You first make to real connection and then you can send the data. A very good example TCP. Connectionless means what? That first you are making a connection, right? I'm just taking an example of that one, okay? But they have a different mechanism. Connectionless is what? No need of period connection. Because in the TCP, what happened first? You have to sync plus sync plus acknowledge, then you can send the data. If the three-way handshake will not complete it, you cannot send the data. I'm just giving a example of connection oriented, right? I'm not telling what technology they are using. Technologies are different thing. No need of period connection. Send the data. UDP. Do I need a period connection over there? No, just send the data. Your CLNS, right, and IP is a part of connectionless. The common thing about these two words is a connectionless. So between these two user, if I want to send out any data, do I need any like a period connection over there? No. And ISS was also designed for, do you know which protocol? Oh, sorry, OSI protocol. And OSPF was designed for which person? TCP/IP. But the good thing about the ISS protocol, guys, it was a way to protocol, and it was a pure, you know, what we call pure link state routing protocol, because the feature of the ISS is better than OSPF. Because what OSPF is doing, OSPF is inheriting the feature of the ISS, right? OSPF is still inheriting the feature of ISS protocol. It is something like OSPF copied all the information of the ISS. You just copy protocol, right? Not the original protocol. But OSPF was totally dedicated for whom? IP. ISS was totally dedicated for whom? CLNS. But the problem of the CLNS, these two guys. एक minute, एक minute. So in 1992, right? OSPF version 1 has arrived and version 2 was introducing in the picture, right? I think so. OSPF version 2 was in 1992. So date, let me check it. OSPF version 2, let's see. This is 2328, right? 1998. But actually they started the, you know, the OSPF came, the version 2 came in the picture in the 90s, 91 or 2, near around. So they introduced the RFC in 1998, but OSPF came in the picture in the 1992, near around. OSPF version 2 introduced. See, the first version was, or the version 2 is the first 1992. So 1991. So near around this came in the picture, but you know, this is written, and before the version 2, it was version 1 also there. It was 1998, if I'm not wrong. Sorry, 1988. And before the 19, and before this guy, ISIS was there. For which person? CLNS. CLNS was the addressing mechanism like IP. So IP was not a dominant on the time. Right now it's a dominant protocol, but on the time it was not dominant. CLNS was good. But CLNS has some issues, right? Like, the multi-homing issue, summarization issue they have. So after that, one more thing, like, the ISS protocol is designed for the OSI protocol, right? For the CLNS one. OSPF is designed for the IP protocol, TCP/IP. After that, in 1992, ISS come with the picture of IP as well as. And in the 1992, they introduced the RFC 111195. I think this one, RFC 90s, 90, in this time they introduced RFC. So 1990. Okay, time, that's not a big deal. So it was for the OSI. After what happened, now it's going to deal with the TCP/IP as well as. I'll explain the dual environment. Just wait for some time. So ISS routing protocol, can you see that, which is maybe used as an interior gateway protocol, IGP, to support the TCP/IP as well as the OSI. So this allow a single routing protocol to be used to support the pure IP environment, at the same time pure OSI environment. Why I'm going to call this guy as a dual? Because this guy is going to support with the CLNS and IP. We can say that it support the OSI model as well as the TCP/IP protocol as well as. And this protocol, then when the ISS was right, when ISS was converted with the IP, now this ISS is known as a. So previously, it was a ISS protocol for which guy? CLNP. And then after that, what happened? When it used the IP, it is called as a integrated ISIS, or sometimes called as a dual ISIS. The reason is called as an integrated ISIS or dual ISIS as well as. The reason is very simple, because now this two guys, right, is going to deal with the two-person CLNS as well as IP. Dual, I'm saying that because this guy is going to deal with the CLNS and IP as well as. That's why it's known as a integrated ISO protocol. So if you are saying the word, if you're pronouncing ISIS, it means that this was the CLNS. If you're saying the integrated ISIS, it means that, okay, you are talking about the IP as well as now. IP plus CLNS. Or either we can say dual IS. So hope this two difference is basic to clear all of you, right? What is the meaning of ISIS and what is the meaning of integrated ISIS? ISIS was the totally for the CLNS. Now ISIS is for the integrated ISIS, called as a CLNS plus IP, both of them. It means that, now try to understand one thing over there. I'll just going to summarize this all information. OSPF protocol is totally a dominant for the which person? IP. EHRP protocol is going to work with IP, IPX, and AppleTalk. After that, what do you call ISO protocol is deal with the which person? CLNS. And ISA-IS protocol is a IGP protocol. IGP means what? It's an integrated routing protocol. So it's not a exterior like a BGP. BGP is the only one single one. ISIS is a linked state routing protocol. It means that they have some kind of LSA as well as, right? But this guy does not have a like LSA that OSPF is using. This guy is a little bit different over there. It is still using the Discastro algorithm, right, to find the shortest path. The ISIS protocol, right, it was developed by DEC, Digital Equipment Corporation. It was the one organization was there. They developed the ISIS protocol for the version 5 architecture. It was the one like, the what we call network setup was there. If you read about the version 5 architecture, it was the near on 120 pages of the one, the module is there. You can read it if you want, but no need to read this, guys, right? It's totally waste of the time. They will not ask you what is the version 5 architecture. Nobody will ask you. Even nobody will ask you who is introduced the ISIS protocol. Just letting you know, the ISIS developed by the DEC, and it is a pure layer 2 protocol. It means that this guy does not have any IP, not TCP, not UDP. Pure layer 2 protocol. And because of this beauty, right? Because of this beauty, nowadays, if I'm talking about the in the DC part, right, in the fabric path, like we are deploying the ISIS protocol in the SDXS. Why this reason the deploying the ISIS protocol? SDXS is the pure LAN environment, right? SD-WAN is a layer 3 WAN environment. SDXS is the LAN environment. In the SDXS, we are running with the ISIS protocol to just avoiding the spanning tree, because the spanning tree is still what? If they are blocking the ports, right? Using the spanning tree, the spanning tree protocol block the ports over there. Any of the one link will be blocked, and even the spanning tree protocol will give the suboptimal routing. We have two types of routing. One is the optimal routing, one is the suboptimal routing in the way of packet forwarding. Suboptimal means what? It's not finding the, it's not going via the best path. Optimal means what? It's the best path. So by using the ISIS, right, in the data center environment, we are just removing the spanning tree as well as we are deploying the ISIS. And with the help of ISIS, what happened? There's no any block ports is happening with it.
So does it do routing in the layer 2?
Yeah.
So it's like MAC and MAC routing?
It's not a MAC to MAC routing, it's IP to IP routing as well as.
In layer 2.
But yeah, they have maintained the, the IP and MAC both information of them.
Okay.
That is a totally part of the fabric path, right, in the DC.
Yeah, because it's layer 2, so IP is a layer 3 thing. So IP, they are doing IP routing in layer 2. That was confused.
So what happened? ISIS protocol is a layer 2 protocol. Still, they can carry your IP information, right? Not IP routing information.
Okay. So there is no spanning tree. There is no support for IP.
Sorry.
So there
it's
is
not
no.
like that. If it's not like that, it's dependent, of course, in the DC environment I talked about. the spanning tree concept, not the enterprise network.
Mani, so spanning tree is not running right on the switches. Then when you enable ISIS,
It's running over there. They are like you're not going to use the mechanism of the ice spanning tree. They are going to use the ISIS protocol in, underlay over there, right? To just avoid the loop. This is the totally a part of fabric, but leave that one. Okay, otherwise I have to go for the fabric path and explain the fabric path. That will take 8 to 9 hours of the lecture of the fabric path.
oh, so for enterprise networks, sir, on the switches ISIS is not enabled. It's only on the routers that we enable ISIS, right?
Yep.
So router में तो anyway spanning tree नहीं चलता है. So where does the spanning tree come into picture?
Spanning tree on the switcher side. अगर तुम्हारे layer 2 में अब मैं SDXS की जो बात कर रहा हूँ तो वो LAN पे ही चलेगा ना तुम्हारा switches पे ही चलेगा.
Correct. So do we enable ISIS on the switches as well?
मैंने कभी enable करके देखा नहीं, but yeah, by default on the SDXS it's enable. तुमको enable करने की कोई जरूरत नहीं है. By default it's enable over there.
Okay. Because telling it's on the SD access on the LAN side, then LAN side पे तो there won't be routers, right? There will still be switches only.
So क्या हो गया?
So
तो
when you
switches पे
are you possible? Is it possible to enable ISIS on the switches on the?
मैंने कभी by default वो enable होता है on the not a pure layer 2 switches, right? Whatever the new switches is coming out there in the market nowadays. The DC environment I'm talking about, the Nexus switches I'm talking about, not the Ethernet like talking the IO switches, cat OS. I'm talking the Nexus part.
Okay.
Well, when you say fabric path, are you talking about Nexus?
Yeah, of course not. Of course, it's not talk about this one.
Does it use the concept of root bridge? It makes a root bridge and avoids the spanning tree loop prevention mechanisms like.
अब देखो थोड़ा सा इधर, थोड़ा सा basic पढ़ो. ISIS. ISIS is used for by the IGP by the most of the tier 1 and tier 2 internet service provider. For the tier 3, it is always recommendation to go for the OSPF and enterprise network. You can go for the OSPF. But a big network like a big ISP, the AT&T is a very good example of the tier 1 right ISP. You can go for the ISS protocol of them. ISS protocol is a more flexibility, right, as compared to the OSPF. It's a more scalable, right? The metric wise, everything wise, this is awesome, right? And it's not going to like put the lots of overhead on the router side as compared to the OSPF. Because still OSPF is going to deal with the layer 3, right? So router has to process the layer 3 packet. But in the case of ISS, what happened? This guy is going to deal with the layer 2, right? So intermediate system and intermediate system. Okay, why I'm going to call this guy as an intermediate system over there? See, according to the IP, right? In the IP terminology, we call as a router. Or device is called as a router. In the term of CLNP, right? So CLNS, we call as an intermediate system. Same way in the IP case, what happened, right? In the IP case, what happened? You are calling this guy as a packet, right? Whatever the packet, we have a hello packet, we call calling this guy as a hello packet. What is the packet? It's a piece of information, right? Chunk of information. Call as a packet. Packet is what? So some small details over there, right? Some informations are there. Hello packet, DBD packet, LSR packet, LSU packet. But in the term of CLNS, right? What happened? We have something called as a PDU, protocol data unit. The OSI model, what is the PDU of the transport layer? What is the PDU of the session layer? What is the PDU of the network layer? So term here will be changed, right? So if you don't understand ISS protocol, okay, you just need to forget something about the IGP. Something forget you have to forget the IGP protocol. Like you need to correlate everything with the OSPF protocol, but you have to forget the EIGRP right now. Because it was totally designed for this person. OSPF is totally designed for the IP. Both are the different addressing mechanism over there. This guy has some issue like a summarization and the multi-homing issue. They resolve with the IP, and IP can do the summarization. That's why we are using the IP in the market, and that's why this is the dominant protocol right now in the market. But the common thing about these two guys is the connectionless. So ISS now it's going to support for the both application, both IP and CLNP application, right?
Which means ISS is both for TCP IP and for UDP, correct?
UDP तो मैंने बोला ही नहीं भाई, वैसा है.
No, because it's
TLNS.
connectionless, right? Connectionless will be UDP, and then again, since it's going to be
IP क्या connection oriented है?
I mean like
हाँ हाँ कहाँ
it's
से?
only it's not TCP, only IP.
IP कब से connection oriented हो गया? IP connectionless protocol है.
Okay. So TCP
क्या?
TCP do not support.
No, it's going to ISS works on the layer 2 protocol. Layer 2 data link layer पे काम करता है वो. Layer 3 का encapsulation होगा ही नहीं उसके साथ. दिखाऊंगा, you wait for some time.
Okay, wait for some time is a good answer.
That's a good one. मैं 5-6 दिन का क्लास लूंगा, 4 दिन का वैसे इसका ISS बहुत प्यारा प्रोटोकॉल है.
Because when you're saying layer 2 ना सर थोड़ा वो कंफ्यूज आ रहा है कैसे
हाँ तो
होगा.
मुझे पता था कंफ्यूजन क्यों लेयर 2 पे कैसे चल रहा है वो, मतलब डेटा लिंक लेयर पे आईपी का इंफॉर्मेशन दे डोंट हैव एनी मल्टीकास्ट आईपी एड्रेस, दे डोंट हैव एनी सोर्स आईपी एड्रेस. मतलब तुम्हारा ऐसा है, दिस आईएसएस प्रोटोकॉल इज गोइंग टू लाइक दिस वन. आई टेल यू हाउ. देखो तुम्हारा अगर मैं ओएसपीएफ इफ आई एम टॉक अबाउट द ओएसपीएफ, राइट, इन ओएसपीएफ व्हाट हैपेंड, वी हैव अ source MAC address, we have a destination MAC address, we have a then type field over there, then we have IPs over there, right? And then after that we have a OSPF header like this one. तो तुम्हारा source MAC में example is A है, and distance MAC हो गया तुम्हारा, हो गया take example, it could be a 01005E 0000000 and then 005. Okay, this is the multicast address for the OSPF. Then we have a 0x0800. This is IP. Then after that we have close IP address will be 101. Distance I will do .5. And then after that we have a OSPF header. And then we have a hello packet like this. ये था ना, सही है तुम्हारा वैसे. तो मैंने तो ये है ना ISS protocol something like this. Source MAC AA distance MAC multicast MAC, मुझे मैं भूल गया क्या है, MAC something 14 is there, I think near around 0 I don't know 01 something called 14 is there. And then after that तुम्हारा ISS video FCC IP का information. There is no multicast. So this is the Ethernet header, right? This is the layer 3 header OSPF. This is the complete is the Ethernet header. No ISS, no layer 3. But let's go. Network domain is also called as autonomous system number, right? But let's go. Once you're done, let me know. Done. इसको ही पढ़ लो यार, ये बहुत प्यारा लाइन। ग्रेट। It just, this line is just going to tell you like why the link state protocol is required a huge amount of process, right? So you have a reason of that one. Trigger a complete SPF over the entire database, whereas distance vector protocol perform the computation on the basis of individual route, not the compared. So this is the reason why, you know, the changes is happening. So a critical advantage of the link state protocol over the distance vector protocol is that capability to support the hierarchical network architecture. Hierarchical means what? You have a layers wise, right? Giving the, like you can have a design. You can, the hierarchical, in the term, the hierarchical scenario, you can design the network according to the like requirement. But that's the, you can do the link state protocol, right, for the hierarchical way. But in the case of high potential, the distance vector protocol works only in the flat network, limited scaling capability. Now, another difference, guys, have a look. In OSPF, what happened? OSPF is also link state routing protocol, right? And in OSPF, what happened? Your metric, right, is depend on the bandwidth. Your metric is totally depend on the bandwidth. It means that if you have a 1 gig link, they have a different routing. If you have a 100 Mbps link, they have a different, they have different metric. If you have a 200 Mbps link, they have a different metric. If you have a 10 gig link, you have a different metric. If you have a serial link, you have a different metric. Algorithm is going to use the same one, SPF, SPF, ISS as well as, both are link state routing protocol. But the only difference is happening between the OSPF and ISS protocol. Not only one difference, it's one of the difference in the metric. You can define the manual cost. Up to you. जैसा मन करो define कर दो. So this is the reason, right? This is the reason the OSPF protocol, sorry, ISS protocol, right? You can easily tune, right? OSPF protocol. अगर तुमको path manipulation करना, if you want to do the path manipulation, you don't need to see the many things over there. कोई फर्क ही नहीं पड़ रहा ना, because ISS protocol does not understand the thing like, you know, what we call bandwidth. उसको तो फर्क ही नहीं पड़ रहा है. That's he's saying that okay, you do one thing, if you change the path, tune the metric. By default, the metric is 10 on every link. Either you have a fast Ethernet link, either you have a serial link, you have a metric is by default 10. If you not change it, you can change it. That's depend on the scenarios, right? If you not change the manipulation, you can do that, you can do that. But is a easy way as compared to the OSPF, right? In the OSPF, yeah, something called as a formula, some 10 to the power 8 divided by the bandwidth, and then after that, OSPF is giving the metric, right? Actual metric. I think the 10 to the power 8 have 7, 8. 7, yeah.
सर इसमें 1 gig link को 10 gig link को कुछ भी हो, कॉस्ट है
फर्क नहीं पड़ता, कुछ भी डालो, तुम पे डिपेंड करता है. So they tuning, see the tuning. Why the person is saying that ISS is a design for the tier 1 and tier 2 ISP, and OSPF is designed for the tier 3, or we can go for the enterprise network. The reason is that this is the one of the reason. तुमको change करना है, change कर दो. Why the ICE is over designed for the big network? Because in the big network, what happened? You have a lots of things, right? Lots of interfaces, lots of things. And how can you manipulate the path over there? You have to check many things, right? The based on the ICE protocol, saying, hey, I'm not going to deal with the bandwidth. Change the cost. देखो, this is the only one routing protocol support IGRP and EAGRP that is going to support the IPX as well as AppleTalk as well as and IP as well as this three one. This is the only two protocol. Again, RIP version 1 and 2 was totally dedicated for the IP. OSPF is totally dedicated for the IP again, right? ISS protocol. ISS the originally developed by the ISO 10589 telecommunication network. Okay, one more thing. CL and PS Wikipedia. Connectionless mode network services, CLNS is simply called the connectionless network services, the OSI network layer protocol, right? So CLNS जो था तुम्हारा, this protocol was developed by the OSI, and it was a layer 3 protocol. Does not require any circuit to establish before the data transfer. That's the meaning of connectionless, right? I don't need to require any kind of pre-circuit over there. Now, if you see one thing, क्या मुझे दिखाना था? I want to show you something else. Yes, this line. CLNS is widely used in the many telecommunication network around the world because ISIS voice routing protocol is mandated by the ITUT, management of the SDH. So when the CLNS, the CLNS protocol has came in the picture, right? It's totally dedicated for the telecommunication networks over there, and the addressing was used in the telecommunication network. That's why it's saying that the ISIS was the ISIS ISO A10589 was originally specified the International Telecommunication Union, right? So the formally the International Organization for Standardization as a routing protocol for the connectionless network protocol, ISIS was the first implemented for the routing within the DECnet phase 5 architecture. It was later, right, adapted to support the IP routing by the IETF, that is RFC 1195. ISS and OSPF has shared a lot of common, but both are linked state routing protocol use the SPF algorithm for the route computation. So if you have a look, what is DECnet 5? So DECnet phase 5 architecture. Yeah. कुछ नहीं है, फालतू है, फालतू का तो नहीं है यार, everything is useful. 129 पेज का ना, इसमें कर रखा है what is actually a DECnet. It's also a corporation over there. हमें इसके बारे में नहीं पढ़ना है, we are only going to deal with the IP. So leave this one. Okay, this is also not important. This is just going to tell you like how the when the router will receive the IP packet and they will propose the header checksum, right? You know, checksum is used for the error detecting, not for the correcting, right? It's just for the error detecting. Sometimes they will ask in the question in the interview. It's not correcting only, just detect it. If there is any error is happening, they will discard the packet like a integrity, just making the integrity of the packet. चैप्टर 1 खत्म हो गया तुम्हारा, चलो चैप्टर 2 पे चलते हैं. ISS. Okay. So ISS is designed for the connectionless in network environment, right? Two types of data communication is supported by the ISO International Standard Organization. Okay, within the framework of the OSI reference model, we have a call as a connection network services (CONS), right? That you have to make a prior connection over there, and then another is a CLNS one, connectionless network services, right? ISS was designed as part of the CLNS environment to provide the necessary intelligence or automatic for the dynamic routing of the data packets. From its inception, this is the reason, right? You know why the ISS is now used for the IS. This is the one of the reason. क्यों लाया गया था? The reason was to bring ISS, right? The reason was to bring ISS protocol into the IP environment just because of this person, still in this environment. Because still in this environment to provide the necessary of intelligence of for automatic and dynamic routing of the data packet in ISO CLNS networking environment. From its inception, the ISS protocol has been adapted for IP routing and other capabilities. So you can use the ISS protocol for the traffic engineering and the multi-protocol level switching as well. So if somebody will ask you why the ISS, right, you know, the theme, nobody will ask you, but I'm just telling you, right, you have a clear the picture of the ISS protocol, like why the ISS came in the picture with the IP, because this guy is going to deal with the connectionless, right? And IP is also connectionless. So वही बता रखा है ISO क्या था? ISO is now currently known as a ITU.
सर वो कनेक्शन नेटवर्क सर्विस करके था ना सर, व्हाट वाज दैट फॉर? ऊपर कनेक्शन नेटवर्क सर्विस कॉन्स करके भी था ना?
तो नेटवर्क सर्विस कनेक्शनलेस अंतर नहीं दिख रहा है क्या तुम्हें?
नहीं, कनेक्शन नेटवर्क सर्विस भी है, कनेक्शनलेस नेटवर्क सर्विस भी है. सो वाज ISS used for connection network service also, cons also?
देख पर क्या लिखा हुआ?
Specified by connection network. Okay.
So configuration wise is very easy. I'm just why I'm giving the theory from the book, right? So that you have a clear picture of the, I can move the configuration right now as well as, okay, like what is the packet types of the and how we can enable the ISS protocol. I'm just telling you the why I'm teaching from this book right now, because as per my understanding, this is the only book which is present right now for the ISS protocol. Okay, and another thing is that it's very important, ISSI, because in the future the ISS comes in the picture, right? Like, you know, SD access is the complete ISS by default, or the data center. If you go ISS, there service provider, you have to go ISS there. Even though some I have seen that, I'm not 100% sure. In the segment routing also ISS comes in the picture. I'm not sure 100%. So ISS is very important. देखो तुम्हारे साथ ओएसआई के 7 लेयर थे, उसमें से 3 लेयर को बोलते हैं एप्लीकेशन सर्विसेज एंड डेटा ट्रांसफर सर्विस. Application means so this 3 layers is going to deal with the application. Why I'm going to use this as a data? Because they have a piece of information, right? अब देखो नया इसमें एक है खेला. What is the CLNS was the connectionless network services, right? That ISS was introduced. ISS is the router to router. ISS I'm calling the integrated, right? Sorry, intermediate system, right? The meaning of intermediate system or intermediate system. ESS was what? And system to intermediate system. ऐसे बताऊं तुमको कि एक पीसी है, ये राउटर है, ये राउटर है, तो यहाँ पे चल जाएगा ESS IS और यहाँ पे चल जाएगा ISIS. ये था, दिस वाज द एनवायरनमेंट ऑफ CLNS, not the IP. This was the CLNS one, not the IP. So if ESS, ISS for the between the and system, right? And system interface system for routing exchange protocol for the use of congestion with the protocol of providing the CLNS, right? So it was used in the CLNS, not in the IP. They have a different like the protocol identifier, right? So no need to read this one because we are not going to deal with it. एक बात है इसके बारे में पढ़ो. The what is the connection is CLNP. Connection network protocol is similar to the IP protocol, right? But specified for the floating network services ISO, right? Transfer protocol. 1 minute. CLNS is the service. CLNP is the protocol. CLNS is the service. S for service, P for protocol. What we call over there? So transfer protocol, rather than the transfer protocol in the TCP IP looks like IP, CLNP is defined really to minimally on the underlying data link layer, which makes it virtually independent of the underlying physical medium. Another thing, your OSPF, right? तुम्हारे OSPF में, in your OSPF protocol, why I'm going to compare with the OSPF? Because IS protocol and OSPF protocol both are same, almost same, not 100%, but almost same. In your OSPF protocol, we have point-to-point network, we have broadcast network, we have point-to-multipoint network, and we have non-broadcast network, NBMA, PMP, P2P, sorry, broadcast and P2P. In the case of ISS protocol, right? We have only two. दो difference clear हो गया. One difference is that OSPF use metric depend on the bandwidth of link. ISS has a manual. The metric of the OSPF is totally depend on the bandwidth of link. Another difference is that This guy has the 4 network types. This guy only 2 network types. The reason is this one. The physical medium, I'm talking about the cable, can either be a point to point in the case whenever you have a WAN connectivity, or broadcast in the case whenever you have a LAN connectivity. Then, so the reason this point is clear, why we have only one, the broadcast and the point to point, the because of the physical medium, because it's going to encapsulate my all the ISIS protocol, right? Whatever the packets of the ISIS protocol, all the packets of the ISIS protocol will encapsulate with the data link layer. It will not go for the network layer information. So we don't have a point of the point to multi-point and non-broadcast network over there. CLNP works on the network layer of the OSI, right? And system to पढ़ने की कोई जरूरत नहीं है. That's not a sense to read it about this one. Okay, leave it. This is also important. Have a look. The ISIS routing protocol. What we want from the ISS, we want interdomain routing, present a global view of the network for the optimal routing decision, link state, provide the faster convergence in the case of failure, and ISS is faster, right, than OSPF. ISS is more scalable than OSPF. ISIS is more flexibility, has more flexibility than OSPF. Provide the network stability and efficient use the network resources such as the router memory, CPU cycle, and the network bandwidth to achieve this goal, right? ISIS was designed as a link state routing protocol. Okay, I'm not going to discuss about this layers right now. Forget it. Otherwise, you guys will confuse this. I'll come to the route when I'm practical part, then I will discuss this. But now, two things is happening over there, guys. Let me reduce the size. What I told you that we have a two protocol, right? We have a two types of protocol. One we have ISIS, and one we have integrated ISIS, or we can call as a dual IS. ISIS is only for the connectionless network services for the CLNP addresses, right? This guy is going to deal with the CLNS as well as an IP as well as. That's why I'm going to call as a integrated, or we can call as a dual. Now maybe you have a question. Hey, log, can we deploy the both of them in the single network, the CLNS and IP? Yes, you can deploy. You can deploy both CLNS and IP in the same network environment. If you have a CLNS address, if the CLNS address is present, you can deploy it. Both will work. That's why it's integrated. It means I can deal with the both of them. If you only dedicated, if you want to dedicate only for this guy, right? Hey, I only need to run the CLNS, go for the ISIS protocol. But if you want to do the both CLNS plus IP, you have to do the integrated. I'll show you in the practical one, like, still right now, you know one thing, if you want to run the, right, if you want to run ISIS protocol, on Cisco router, you still need CLNP address. Still required. And even on the Cisco router, most of the command, right? Not most of the command, some command, 50% we can say that 50% of the command is running with the CLN. Okay, some command just like so CLNP you have to write, so CLNS you have to write, so ISIS you have to write. So it's not like that we are completely removing the CLNS. Still there. If you want to run the ISIS protocol, you first need to define the, and this is the mandatory, right? This point is mandatory. I'll show you how the CLN address will look like this and whatever the information will be there, but you still need a CLNS address. Without CLNS, you cannot deploy the ISIS. You need to do, like, I can simply say that without, CLNS, you cannot run the ISIS protocol on the Cisco router. You still need it. So if you see two things, right? One is the ISS routing protocol, and one is the integrated IS. Both are different one. It's not the same. This was the ISS is for the CLNP, right? CLNS environment. Again, it's a services, it's a protocol. But I integrate ISS, it's saying that hey, I can deal with the both of the person. I mean, you call this guy as a integrated. Why? Because RFC 1195, right? The use of OSI ISS for the routing in the TCP environment, or we can say the dual environment, according to RFC. If you see the RFC as well as, is right. So yours. Right, you can see that somewhere it's written. Was that, man? Yep. So based on the OSI interdomain ISS routing protocol, which may be used Internet Gateway Protocol to support the TCP IP as well as the OSI. This allows the signal routing protocol to be used to support the pure IP environment at the same time pure OSI environment, or we can call as a dual environment as well as. So you can write on this point is very important. If you know, right, you can have a look at the RFC as well as this, given all the RFC as well as. So that's why it's called as a dual environment integrated ISS protocol, dual ISS, right? And up for the IP routing as well as and CNNS as well as. So there's a OSPF usually support the IR for only layer 3 protocol. OSPF deals with the IP routing. Integrated IS can be used for the routing in the CLNP only or IP only, as well as in the dual environment as well. So I told you, right, you can do the ISS protocol in the both environment. Either you can run with the CLNP, right? Either you can go for the IP or either you can go for the both of them. इतना ही करते हैं आज के लिए, बाकी कल देखते हैं practicals. So tomorrow we'll do the we'll go for the hands-on little bit on the Cisco router. So tomorrow I'll show you how the ISIS is going to work and how to enable the ISIS and some packets as well as, and then day after tomorrow we'll go for the redistribution part, summarize and this kind of stuff. Okay, any questions, anyone? Okay, we have a 5 days class of the ISIS protocol, 4 to 5 days. So I'll complete you this book, don't worry about that. So you will not have any questions from the ISIS protocol. Yeah, go on.
So Nexus switches are going to be on the lab.
No.
No.
No. I'm just there teaching this ISIS protocol as per you, what we call request. Swami has requested for the ISS for nothing else.
Oh,
ISS is not there in the lab, like in your examinations. SD access ISS is there, but by default, as I know that by default it's enabled over there, right? So you don't need to manually enable over there. So you are not going to deal with the ISS. But yeah,
Even in the
ISS is
theory
very
part,
important. Yep.
even in the theory part also ISIS is not there.
Theory part, of course, theory is there. If you go for the CCNP ENCODE examiner, some questions is coming theory, like a very basic questions is coming, not the high level. I'm just teaching you that ISS for it's not a part of like 1 minute. Let me pause the recording.